Okay, good morning, afternoon, everyone, whatever it may be for you. I am out today, so I want to give you just a short little video here to talk about how we're going to solve nonlinear systems. I'm going to do 3 examples for you. The first example is how do you solve nonlinear systems by graphing, and then the second example is how do you do it by substitution, and then finally by elimination. So I will do each of these first examples here and then throw up the answer to the other one if you'd like to try it by yourself. So first one's first, solving a nonlinear system by graphing. Essentially, you use this method when both equations equal y. So let me write that down, both equations. Let's say this, have a y equals on them. So both equations have y equals, all right? If you want to do it by a graphing calculator, here are the 6 steps to do it right through here, but we're going to do it by Desmos. And so if I want to solve these two things by graphing, what you're looking for when you graph them is you're looking for intersection points. Okay? So if we have, so it's possible to have one answer, it's possible to have 2 answers, but it's also possible to have no answers there. So let's go ahead and jump over to Desmos, and I will type those 2 things in, and we will figure out what the answer is and how do we solve the system. So our first equation, y equals x squared minus 2x minus 1, and it looks like that. And our second equation is y equals negative 2x minus 1. So what you're looking for where they intersect. And so we got to get really, really close. Looks like it only intersects in one spot right there, which is 0, negative 1. So what that means is, go here, is that how do we solve the system by graphing? It is, the answer is going to be the intersection point, which is 0, negative 1. Okay? So what that means is if I plug 0 into this equation right here, the top one, I'm going to get an answer of negative 1. So y equals negative 1. And you can see that's going to be true for the second one. Also, if I plug 0 into there, we get an answer of negative 1. Okay, so that's the general process there. If you want, go ahead and take a look at this one. Go ahead and do it. Plug both of those into Desmos. See where they intersect. And you get an answer of 6, 0 is what you get for that answer. Okay? All right. So that's the first method. Pretty straightforward, I hope. Second method, solving a system by substitution. And I'm going to focus specifically on this problem right here, and then I'll throw what we need to do for the second problem up on the overhead. Actually, you know what I'll do? I will make a copy of these notes and email them to everyone, so you'll have them. Okay, so solving systems by substitution. When do we use this? We use this method when we have one equation that's in standard form, and the other equation, and we also have one quadratic. So let me put down one quad right there. One quad is what I wrote down. Okay? So if you look at this here, notice we've got, this is kind of sort of in standard form here. Okay? And actually it isn't standard form, all right? My apologies. So standard form usually has the letters on one side and the number on the other. Okay? This right here is also in standard form. Okay? Because we've got the letters on one side and the number on the other. So first thing we want to do, so if we put a little bullet here, what's our first step? We want to solve our linear equation for y. So solve linear equation for y. Okay? So my linear equation is this bottom one here that's got x plus y equals 4. We want to solve that for y, so all we need to do is to take away x from both sides. And so now this equation right here becomes y equals negative x plus 4. So that's the first step we want to do, solve our linear equation for y. The next thing we want to do is we want to substitute this, the x minus 4, in for y into the other equation. So I'm going to say sub in for y. Okay? So I'm going to take this top equation, x squared plus x minus y equals -1, and I'm going to write it x squared plus x minus, instead of y, I'm going to put this negative x minus 4, plus 4, excuse me, equals -1. So what I really did is I took this and I plugged it in right there, substituted it in, and you can see where I substituted it in right there. Okay? And so that's what we have. We substituted in for y, and now we want to go ahead and get our equation equal to 0. That's what we'll do here. So I'll say EQ equal to 0. Okay? And then we want to use the quadratic formula to solve it. So I'll just put QF for quadratic formula. All right, so let's go ahead and simplify this thing. Well, the first thing we need to do is we need to distribute this negative to the parentheses. So we're going to have x squared plus x when I go negative, negative, minus 4 equals -1. And then, so that's really x squared plus 2x minus 4 equals -1. Combining these two x's to get 2x. We then need to get it equal to 0. So our equation is equal to 0. So I need to add 1 to both sides. And so we have x squared plus 2x minus 3 equals 0. Okay? Now we want to do the quadratic formula. So equation equal to 0, quadratic formula right here. So we have a equals 1, b equals 2, c equals -3. And we do the quadratic formula. X equals square root of b squared, 2 squared, minus 4 times a, which is 1, times c, which is -3. Sorry about that extra noise. It is the dishwasher right there that is going off, so my apologies. All right, so we have that. The whole thing is over 2a. Whoops, 2 is not 2a, 2 times 1. And we simplify things. So we simplify underneath that square root. And so 2 squared minus 4 times 1 times -3 comes out to be 16. So we have -2 plus or minus square root of 16 over 2. Square root of 16 is 4. -2 plus or minus 4 over 2. Square root of 16 is 4. Now, since this is an integer, we can break this up into -2 plus 4 over 2 and -2 minus 4 over 2. Anytime we have that integer, we can do that. And so -2 plus 4 is 2. Divided by 2, we get an answer of 1. -2 minus 4 is -6. Divided by 2, -3. And there are your two answers. So we want to clean it up. X equals 1 and -3. And that's solving systems by substitution. You take your nonlinear, or you take your linear equation right there, solve it for y, which is what I did right here. Take this, since we have y equals -x plus 4, I can take this -x plus 4 and put it in place of y in the other equation. And that's what I did here. So instead of x squared plus x minus y, it becomes x squared plus x minus whatever y is equal to. Get our equation equal to 0, and then the quadratic formula. So your three basic steps are right there. Okay? Okie dokie. Now, what else we have to do to finish this problem off is we have to figure out what y is. I forgot to mention that. So we got to figure out a value for y. So let me find a piece of paper here real quick. Ah, wonderful. So now that we know what x's are, we have to figure out what y is. Okay? So last part of this problem that I almost forgot is we have to take x equals 1 and x equals -3, and we got to plug them into the equation. So let's plug them into the equation y equals -x plus 4, which is from right up here. Okay? And so we have to figure out what y values go here with the x, -1, and x equals -3. And so if I plug 1 in here, I get an answer of 3. So that means, whoops, sorry. That means that one of my answers is 1, 3. And over here, I plug -3 in, and I get 3 plus 4, and that equals 7. So that means I get -3, 7. Okay? So we need to add that step on because we're solving for a system. So we have to have an x and a y and x and a y. Okie dokie. All right, so let me rephrase that one last time. How do we find x's? Solve our linear equation for y right there. Substitute in. Okay? Substitute in, get the equation equal to 0, and then use the quadratic formula. That gives me two answers, -1 and -3. I then take these two answers for x, and I plug them into one of the above equations, preferably the linear one, to get the y-coordinate that matches up with x equals 1, and to get the y-coordinate that matches up with x equals -3. Okay, so that's solving by substitution. Solving by elimination. Solving by elimination is not bad at all. So what we have to do, or when we use this, is when we have equations in standard form. And both of these are quadratic. So both of these equations are quadratic. They have second degree polynomials. So what we're looking for in elimination is we're looking for opposites, and we want the y's to be opposites. So make y opposite. Once we have y's that are opposite, you can see right here our y's are already opposite because this one's negative, this one's positive. We add straight down. So since you have opposites, add. So we go 2x squared plus x squared is 3x squared. -5x plus 2x is -3x. The y's cancel, and it equals -2. Now, equation equal to 0, and quadratic formula. So, bring the 2 over. 3x squared minus 3x plus 2 equals 0. And a equals 3, b equals -3, c equals 2. Quadratic formula. 3 times 2, a times c, all over 2 times 3. And when we simplify all of this here, 3 plus or minus square root of -15 over 6, because this all comes out to be -15. We know how to handle square root of negative numbers. Plus or minus I times the square root of 15 over 6. Notice we get imaginary or complex number. Oh, there's the cat. Hopefully you can hear it. The answer is no solution. No real solutions. All right, so those are your 3 steps. Go ahead and